Hello again, and welcome to another episode of Python for Programmers. So, we're getting through some of the advanced features of Python, and some of the few at the end. I suggested you look at the manual and get the details you need because I've covered most of the differences. But one of the things I'm going to look at today, and let's do an Alt tab for you. So let's get rid of our slideshow, and what I'm going to look at now is focusing on portable Python. So Python is a language that runs on many platforms and that we've always talked about, and so here I've got a little Python program to explain some of these, and I've got different versions of Python here. So let's first just look at that. I'm running in the idle shell, so I've got it in an editor. I just happen to have it in the Notepad++ editor, and I'm running on Windows 10 here, and there'll be reasons for that later. So if I wanted to run this little program in idle, I could run it for you. And here's my little program. It runs in Python 2, but some of the features of the program cause problems with Python 2, and that's one of the things I want to talk about, is how do you get Python source code that works for everything. So I also have idle for Python 3 running here, and I can open the same identical program from my file store, and I can run this program here. So we can compare the results here. So here it's running on Python 3.9 in 64 bits. Here it's running on Python 2.7 in 32 bits. We're both on Windows. And on the Python 2, it has a problem with this statement, and Python 3, it has trouble with this statement. So it's possible to get problems on all the Python, and that's really what we need to talk about. And here I've got it in the Notepad++ editor, so you can see the whole program. It's more suitable than Jupyter Notebook, which I've shown in the other episodes. So what have I got here? So here is my main program. So one of the things of portable programming is, if you want portable Python scripts, it's recommended that you put your body of code in a main program, and you have this line of code at the bottom that invokes the main program and then exits in the various Python portability documentation. So everything is indented in there. I've put some commenting in here. So there are system variables that allow you to inspect the version. So it can work out that I'm on Python 2. You can see it says it's on Python 2, and it's able to extract that from the system variables. So by at the top importing sys, I was able to work out what I'm on. Also, there's a sys variable platform. I can work out whether we're on a Mac or Windows or some other platform here. So you can write code that can implement something slightly different depending on your platform, but really you should try and develop your code so you don't have to do this very often, that if you write your code the correct way, it is portable. So quite often, if you're teaching, it's better to teach your students a subset that will work for them, whatever they have on their platform, rather than working with the latest. Now, if you were working in a different environment and you were in control of the platform, then you could write for that particular platform. But I'm just flagging out what you do. So although Python is supposed to be portable, there is some irritation to it on how you write universally compatible code. So what I've shown is the difference here. So one of the differences is in string concatenation. Now nearly every Python version has string concatenation that works, in other words using the plus operator, and you can see that string concatenation works. But there were in the past some issues, so there are some recommendations that you can actually join your strings. So I've done a string join. So notice I put try and except round them, so if there's a fault I can print out that it did not work, and of course here it has universally worked. So this is my program for testing portability. So string join will work like this. So I've defined a function that takes a variable number of arguments, and I've used join and a map to universally concatenate these things together with a null string. You could concatenate them with a space, but that's not what we want. We want to concatenate them together with a null string between them. So that's one way of achieving portability. So, and this confirms that that worked. Another feature that was added to Python during its lifetime is formatted strings. So there's a dot format method on a string object, but also there's f in front for formatted strings. So I've tested them both, and you'll see here that the formatted strings works in Python 2, and formatted strings works in Python 3. So there's no problems there. But this f in front and using the curly bracket for string formatting doesn't always work, and actually generates a syntax error, and this wouldn't compile as it shows here. So in Python 2 this does not exist and doesn't work, and would generate a syntax error such that none of the rest of the script would run beyond that point. So I've cheated here. I've made a method to recursively execute that string such that if there's an error we can continue on. And that's what I've done. I've continued on. And another difference in Python forms is the print command. So in Python 2, print was a statement and therefore it didn't need parentheses, but in Python 3 it is a function and does need a parenthesis like here. So if you put print space and then its argument, that would fail in Python 3 like this. So again I've cheated and done a recursive call on Python. But there is a way around it. So the way around it is always put the parentheses in, because in Python 2 it would see that as an expression in parentheses preceded by the statement keyword. But to Python 3 it looks like the function call or method call. So print can be made universal, string concatenation can be made universal, and if you use the dot format method of formatting a string, that's universal. So you can try and do things in a universal and portable way between Python 2 and Python 3. So, but I have shown some other things. So I took the opportunity in making the recursive call of Python and show you some other things that in other languages might be operating system specific. They're done in operating system independent ways on Python, and you should try and do that. So for example, I needed to create, well I didn't have to, I could have done it all in line. So those of you who might know the Python command might say, why did you use a file? You don't need to use a file. Because I wanted to show portability in file operations, so I can create a named temporary file that I want to write to that has a lifetime beyond the closure. So, and basically I put the Python statement in a file, and then I created another named temporary file to capture the output, and here I've done a portable subprocess call on the Python executable. I don't need to know where it lives. I don't need to know the name of the temporary file for the source, or the temporary file for the output. I've just sent the output to my result file. I've listed the result file, and at the end of this context manager, the file is closed and deleted. I don't have to worry about it. So at the end of this Python execute method, both of those temporary files have gone. It's shown here the name that it gave, and you notice it shows a different location on the different Python systems. So I've shown that running between Python 2 and Python 3 on a Windows system. I could equally show you that working between Python 2 and 3 on a Mac. So let me call that up. Okay, so magically we've switched to a Macintosh, our Mac OS environment and an Apple environment, and here I happen to be viewing the exact same script, and it's actually from a network file store, so it really is the same file. If I make edits on Windows or a Mac, the change is seen on both systems, which will be interesting for our experiment later on. And I could use idle, but as I said in my introductory video, idle can be unreliable in a Mac environment. But I can run Python on this portable file, the same as I run, and here I get the same output for Python 2, but it's now Python 2 on a Mac, and this is a 64-bit Python 2. And on the Windows it was a 32-bit Python 2, but I get the same errors, and I can run it on Python 3 on my Mac, so I've got 64-bit Python 3, and I get the same faults and the same part information as it did. So this program works portably between Python 2 and Python 3 and all platforms, but does illustrate the difference. And I haven't done a screen capture of it, as I haven't bothered to link it up, but here is Python 3 running on my Android phone with exactly the same program from the same file store as you've seen there. Portability. Just get it in the right environment. Is it all straightforward? No. So, what if I wanted to make some changes to this program? Let me talk about the problem. So let's say I wanted to add something. So sorry about that. It got changed in the other environment, and Emacs picked up on that, which is good. Let's say I wanted to make a change to this program, and I wanted to print we are on a Mac, and I wanted to write. Wonderful. Well, that's really good. Now these print statements, it all looks good. So let me save that file, and now let me run that file on Python 3. I've got an error. I've just used the editor. It looks wrong, and it says inconsistent use of tabs and spaces and indentation. What has happened? So what has happened. This is what's happened. So I've turned on the mode in Emacs that makes control characters white space visible. You can see here this line is tab tab, and Emacs has automatically added in spaces. So one of the ways of being portable is don't use tabs, and certainly don't mix tabs and spaces, because Python won't see the indentation the same as you do as a human on the screen. And say I was to switch back to the Windows environment, what happens in the Windows environment? We have the same problem. So hopefully this notices that I've got this there, but of course I will get the same error in this environment. If I close the file and reopen it, so you'll notice it in here, actually idle does show a different indentation. It does show the problem, and if I run it I would get the indentation error. So let's close that. But also we can view, so if I make all white space visible again in Notepad++, you can see I've got a problem. Is that just an Emacs problem? Well, let's try adding a line in Notepad++. We get the same problem. So there is inconsistency of how the different editors work, and you should universally replace all tabs with spaces. So it's much better if I did a find and replace. So let's do a find and replace. So let's find all \t's and replace with 1, 2, 3, 4 spaces. Replace all in this open document. Now we will be better. So if I go to here and I run, we now can run OK, whereas before the program looked the same in the editor and it didn't run OK. So we can now go back to our Mac environment. So let's go to the Mac environment. And you can see even in the Mac we now have no tabs, it's all spaces, and the error has gone. So, in summary, you can write portable Python that works in a large variety of arguments. You can teach and learn to write code that's more universal, but it is possible to have environment-specific code. You can test your environment either by operating system or processor platform of 32-bit or 64-bit. You can test that. You can write specific code for the different environments. It is possible, but you have to plan it. So just because your code works doesn't mean it works for everybody unless you're careful. So the thing to do is use the right APIs, manipulate files and process calls in a portable way rather than calling the operating system directly, and do certain things like for formatting output, use the not the most advanced or modern features for doing it. Use something that's more universal, which is the dot format method, and for print, make sure you put parentheses in. So those few things, and use a main program. So those few techniques can give you code that's much more portable across platforms or will run on unknown platforms. Now there are genuine reasons why you might want to know. So for example, some libraries like TensorFlow needs a 64-bit platform, so sometimes you do need to test that you're running with a 64-bit version of Python for certain libraries. But it's better to be aware of the differences. So I hope you found that useful. All I'm missing now is how to download the Python for your different environments. I'm probably not going to show that because I'd have to delete the Python from my existing systems and reinstall it from scratch to show you how it's done, or find a clean system to demonstrate on. But the instructions on the official python.org site are the main ones to be trusted to do that. And that's mainly what you should follow, and except for Android. So for Android, don't download what's available on the Play Store. You probably need to get it from F-Droid to get all the things working properly. That's what I had to do to get a good environment on my Android system. Interestingly, Android apparently appears to be the most powerful processor I have available to me at the moment. Anyway, thank you very much, and I hope this series has been useful when I've taken you through from Python, from nothing all the way through to more advanced things like portable programs and running and editing larger programs. So thank you for your time. It's been good to work with you. And I'll be working on my next series, which will probably be Pythons for beginners. Thank you very much, and have a good day.